In previous videos, we reviewed how to set up predictive algorithms directly in Microsoft Excel. Now we are going to take it a step further by utilizing those algorithms to help automate our variance analysis. Because we have a model that reliably predicts receipts, we can start to unpack why actuals vary from those predictions. We'll start by asking Copilot to create a new script that will extract the coefficients of our linear regression model. These coefficients will provide weights for our model inputs that we can then use for variance analysis and scenario analysis. Notice that the outputs from Copilot are not perfect. You should never expect them to be perfect. You will need to iterate until you get the script running as you intend it to. There is no shortcut for this, just experience and practice, but trust me, it's far faster than doing this all manually, and as you get more experienced you'll start to learn how to do this all yourself anyway. In this particular instance, the Python script is identifying the coefficients, but the outputs are displaying incorrectly as arrays and then incorrectly again as tuples. We need to keep nudging Copilot until it provides us a data frame or Python's equivalent of a table. After a couple of attempts, our iterative feedback finally gets us to where we want to be. Perfect, now we have our coefficients. Let's just clean the sheet up a bit to keep only what we need and then clean up the formatting. Next, let's start defining the parameters of our analysis. We're going to create a data validation dropdown for the user to select the week for analysis. Note the use of array formulas, which will automatically update as soon as new data is added. Next, let's build the table for variance analysis. Each line will be related to the coefficients. We will populate each item in this table across what we forecasted, what the actuals are, and what the variances were. Only the forecast will have an intercept value. This intercept residual variability in receipts that is not explained by one of the independent variables. Now we get to the drivers by multiplying the forecast variance by the weight of each respective coefficient. To understand the actual residual or unexplained variance, we take the difference between total variance and the sum of the drivers. Notice that the variance and drivers equal each other. Now we can just clean the format up a little bit. This table looks like crap. At this point, we have all the ingredients to the variance analysis. Each driver articulates the variance attributable to each individual variable. Keep in mind this is made-up data and the correlation on these variables is weaker than we'd like in a real-world scenario, so your intercept or unexplained driver should not be as large as what you see here. The last thing we will do is put a visual together for reporting purposes. I'm not always the biggest fan of waterfall charts, but these are a staple across the world's FP&A departments. Luckily, Excel added a native waterfall chart a couple of years ago. And here is the best part, because of how we have this set up, I don't have to mess with any of these numbers. As soon as I add more actuals data, my predictive model will get retrained. As soon as I change the week, I already have my first draft variance analysis complete. I can taste the Type 2 savings already. If you like this content, smash that like and subscribe button, and if you want more, check out my Substack, The Ref Report. Next, we'll take this another step further and build out scenario analysis using the same predictive model. If you're interested in that, it's coming up on the screen now.